Welcome everyone. I am Baby Anitha, Associate Professor, Department of CSE, KSO College of Engineering. Now we will discuss about the tree concept. Here the tree is nothing but is a hierarchical data structure. It consists of information in the form of hierarchical manner without any closed region. It is one of the powerful and advanced data structure. It is a non-linear data structure. Here, here the tree can be represented the nodes connected by the edges. This is an example of structure of the tree. Here the A is a parent of B and C. A B is a parent of D, E and F. Also, D, E, F is a child of B. Is an example of the tree. Here the tree is a collection of elements called node where each node can have any number of children. Here in any tree with the n nodes there will be a maximum of n minus 1 edges there. In this example the node having a 11 tree with 11 nodes and 10 edges. Here we discuss about the some tree terminologies. These are the some tree terminologies. So root, edge, parent, child, sibling, internal nodes, degree, height, depth, level, path and subtree. The first one is the root. In a tree data structure, the first node is called as a root node. In a tree, there must be only one root node. So no, never multiple root nodes in the tree. In these examples, A is a root node. Remaining nodes are internal nodes or parent nodes or child node or leaf nodes. So second one is the edge. The edge is a nothing but is a connecting two nodes by using link or edges. Connecting link between any two nodes is called as a edge. In a tree with n number of nodes, there will be a maximum n minus 1 number of edges there. As the next one is the parent. In the node which has one or more children is called as a parent node. A parent node can have any number of child node. In this example, A, B, C, E and G is a parent node and the remaining is a child node. As a D, E, F is a child of B, B and C is a child of A. The node which is predecessor of any other node is called as a parent node. As the next one is a child. All the nodes except the root node is called as a child nodes. Here B, C is a child of A, D, E, F is a child of B, C, G, H is a child of C. So next one is the sibling. So sibling is nothing but so node with the same parent or sibling nodes. So node which is belongs to the same parent are called sibling. Here B and C is a sibling, D, E, F is a sibling, I and J is a sibling, C and H is a sibling. So next one is the uh, sibling. Next one is the leaf node. A node which does not have any child is called as a leaf node. The leaf node is also called as a terminal node or external nodes. Here D, I, J, F, K, H is a leaf node. That node does not having a child. A node without successor is called as a leaf node. If any tree, the node which does not have children, that node is called as a leaf node. So next one is the internal node. Yeah, a node which has at least one child is called as the internal node. In the tree, any one of the node having a one child, at least one child is called as the internal node. The internal node is also called as a non-terminal nodes. Every non-leaf node is a internal node. In this diagram, uh, A, B, C, E, G is a internal node. Remaining are leaf nodes. The leaf nodes does not having a child. Next one is the degree. Degree of the node is the total number of children of that node. That is a particular node. The degree of the tree is the highest degree of node among all the nodes in the tree. In this example, highest degree of node is B is 3 because the B having a 3 children. D, E, H is the highest degree. What is the degree of A? That is a 2. What is the degree of F? That is a 0. So the F node does not having any child. So the what is the degree of F means 0. As the next one is the level. In the tree, each step from top to bottom is called as a level of tree. The level count start with 0 and incremented by 1 at each level. For example, here start with level 0 and any number of levels. So next one, height. Height is nothing but that is a total number of edges that lie on the longest path from any leaf node to particular node is called as a height of the tree. Height of the tree is the height of root node. Here all the leaf nodes height is 0. What is the height of A? Height of A is a 3. For example, the height is 3. That's a leaf node to that node. That is a leaf node K to A. That is a leaf node to that node. The height is 3. What is the height of K? 0. What is the height of E? Is a 1. What is the height of B? 2. That is a leaf node to that node, it is a height. Next, depth. Here the total number of edges from root node to particular node is called as a depth of that node. So depth of the tree is the total number of edges from root node to leaf node in the longest path. Root node to leaf node. That is a depth of A is 0. So depth of K is 3. So next one, path. That is a sequence of nodes and edges from one node to another node. That is a total number of nodes in that path. It's a path between the two nodes. For example, it's a path between A and J. A and J. That is a A to B, B to E, and B to E, and E to J. What is the path between A to K? That is A to C, C to G, G to K. This is a path. As the next one is the subtree. Each child from a node form a subtree recursively. Every child node form a subtree on its parent node. In this diagram, we are considering about the three subtree. That is a B is a parent of D, E, F, and E is a parent of I and H. Here is a 2 subtree and C is a parent of G and H. G is a parent of K. So this is a 1 subtree. So totally in this diagram 3 subtrees are present. As the next one is the binary tree concept. What is a binary tree? What is a normal tree? What is the difference between the general tree and binary tree? It's a normal tree, nothing but every node can have any number of children. Is a one node having a one children, two children, or three children, or four children. But in a binary tree is a every node can have a maximum two children. One is left, other one is right child. That is a maximum of two children is called as a binary tree. In a binary tree, every node can have either 0 children or 1 children or 2 children, but not more than 2 children. This is the declaration of binary tree by using the structure. That is a struct, T node is the structure name. Inside this structure, to declare the three variables. That is the int element, left child and right child. Is an example of difference between the general tree and binary tree. It's a general tree, each node have any number of any number of child, any number of nodes. The one node can have a one child, two child, three child. But in a binary tree, it have a some rule. Each node can have a two children or one children or zero, not more than two. This is a binary tree. It is a name implies we can tell binary means two. So each node can have a only two children. Is some type of binary trees. So these are the following type of binary trees: rooted binary tree, fully or strictly binary tree, complete or perfect binary tree, skewed binary tree, almost complete binary tree. Is the first one, rooted binary tree. Here every tree can have a root. Each node has at least two children, at most two children. That is called as a rooted binary tree. This is example of rooted binary tree. Every tree can have a root. Next one, full or strictly binary tree. Here, in which every node has either zero children or two children. That is called fully binary tree. It is also called strictly binary tree. It is an example of strictly binary tree. The first node, the first diagram, the C node having a one child. In our rule, strictly binary tree, either zero child or two child. The second diagram is a correct one. As a next one, complete or perfect binary tree. Here the every node exactly two children. All the leaf nodes are same level. It is exactly two nodes. All the internal nodes exactly two children. That is called as a perfect binary tree. Is example of perfect binary tree. Each node exactly two children and all the leaf nodes are same level. That is called perfect binary tree. It's a next one, almost complete binary tree. Almost complete binary tree that satisfy the following properties. All the levels are completely filled except possibly last level. The last level must be strictly filled by left to right, not right to left. In this example, the C having a right, the C node having a right child, not left. So it is not a complete, almost complete binary tree. Here the nodes can be filled from left to right, not right to left. So second diagram is correct, the first one is wrong. So next one, skewed binary tree. The skewed binary tree consists of two way, left skewed binary tree and right skewed binary tree. Here some properties. Here all the node except one node has one and only one child. The remaining nodes has no child. As a skewed binary tree is here such that is a depth is n minus 1. For example, is a the first example is a left skewed binary tree. The second one, the right skewed binary tree. Is a left skewed only left child, no right child. A right skewed only right child, no left child. It is a two type of binary skewed binary tree. Is a next concept is a binary tree representation. How the binary tree can be represented? We are using the two way to represent the binary tree. The first one array representation, second one linked list representation. The first one array representation, we are using the one dimensional array to represent the binary tree. Here how the element can be positioned. For any element position is I equal to 1, the left side position is 2i, the right side position is 2i plus 1, the parent is a position of I by 2. These are the steps for to convert the complete binary tree. First of all, the given binary tree can be converted into complete binary tree by adding a empty node. What is a complete binary tree? Every node have two child and all the leaf nodes are same level. It is a rule for complete binary tree. Second one, and give the index for the every node from the root to leaf, and size of the array is equal to the number of nodes in the complete binary tree. This is a binary tree example. In this binary tree can be first of all to convert it into complete binary tree by adding a empty node, by adding a empty node. This is to add the empty node for a node F, G and H. That is all leaf levels are equal in complete binary tree. And then to fix the to put the index for every node from root to leaf. That is the index 1 for A, that is a root node, that's a level 0, and then level 1, and then level 2, and then level 3. Okay, wow. It's a put for index for the every node based on the level, that is a 1, 2, 3, 4, 5. So totally 50 nodes are present in the complete binary tree. So what is the size of the array in the complete binary tree? It is equal to 15. So 15 arrays, that is a 1 to 15 or 0 to 14. That is based on the array position. The index 1 to put the A, index 2 to put the B, index 3 C. So, so far index 13 to put for K. The remaining index are empty node, so to put the null value. So next one, a linked list representation of binary tree. Here using the doubly linked list to represent the binary tree. What is a doubly links? Here the every node consists of the three field. The first field for storing a left child address, second field for storing the data element, third field for storing the right child address. In this diagram can be there's a doubly linked list is a left child address to point to the address of the previous node. The right child address is point to the address of the next node. Here the data can store the data value. This is an example of binary tree representation by using a linked list. What is mean null? That is the left side. The left child address does not have any previous node. The right child address does not have any next node. So it put the null value. So next one, these are the some application of tree, where and all the tree can be used. These are the some application of the tree: heap chart, a B tree, B plus tree, and compiler use the syntax tree to validate the syntax of every program you write. These are the some applications of tree. As the next one is how to calculate the number of nodes with the binary tree of height 2. We are using the some formula how to find the height of tree, that is a 2 power h plus 1 minus 1 node. Here the height is 2, therefore number of node in a complete binary tree is 2 power 2 plus 1 minus 1, so 7 nodes. So to draw the 7 nodes, all the leaf nodes are equal. Next one is the tree traversal. What is a traversing? Traversing means visiting each node only once. Here the tree traverse is a method of visiting all the nodes in the tree exactly once. Here all the nodes are connected through edges. We always start with the root of the tree. That is a starting, or to follow the order. That is, we cannot randomly access a node in a tree all the time to follow the order. There are three type of tree traversal: in-order traversal, pre-order traversal, and post-order traversal. What is in-order traversal means? In this traversal, first to visit all the nodes in the left subtree, and then to visit the root node. After that to visit all the node in the right subtree. That is L small or capital R. As a left, root and right. That is in order. Next one is the pre-order traversal. Pre-order traversal, first to visit the root node, and then left subtree node, and then right subtree node. That is root, left, right. That is called pre-order traversal. So next one is the post-order traversal. Here visit all the nodes in the left subtree and visit all the nodes in the right subtree And finally to visit the root node, that is left, root and right. This is called post order traversal. Is an example of pre-order, post-order, in-order. Is a tree. How to write the in-order? In-order, what is the rule? First of all, to visit the left subtree and root and right subtree. So in-order traversal, first left A and then root B and then right C. As a next pre-order traversal, pre means root left right. First visit the root node B and then visit the right node A and then visit the left node A and then write the right node C. That is a BAC. So next one, post order traversal. First visit the left subtree and then right subtree and then root. So left A and right C and then root B is a some small example of tree traversal, in order, pre-order and post-order traversals. And then example 2, this is a binary tree. First one is in order. In order, what is the conditions? First visit the left node and the right node and then root node. So first left, left to visit the left, left subtree and then right subtree. In this diagram, the first left subtree and right subtree. In the left subtree, to first visit the left node. So D and B is a root and E, and then root A and then right subtree. Right subtree, first visit the left node F and root node C and then G is the example of in order. And pre-order, what is the rule? Root left right. First of all A and then left, left and then B is a root A B and then next left A B D and then E and next move to the right subtree. Right subtree, first what is the root? C. What is the left? F. What is the right? G. That is it is a rule for traversing pre-order. Next post order, what is the rule? Left, right and then root. First of all to visit the left subtree and right subtree and then to visit the root node. In the left subtree, what is the left tree? Left node D and right node E and root B and right subtree F, G, C and finally visit the root node A. That is a post order left, right and root. This is a rule for post order. These are the recursively routine for in order travels. This is a program for in order traversal, pre-order traversal and post-order traversal. So first of all, in order traversal by using the void in order node start t if t not equal to null. What is a not equal to null? If no node in the tree, so not equal to null. So it move to the in order left data, that is a root and right. Similarly pre-order and post-order. This is some example of in order, pre-orders, post-order. These are the some examples of in order. Okay. As a next topic, expression tree. This is will be discussed in the later session. Thank you everyone.